Texan Global School. Solids, cone. This class discusses the general characteristics of the cone's surface area and volume calculation. A cone is a solid bounded by a conical surface and a plane, called base, which cuts all its elements. It has a vertex, radius, height or altitude, and a lateral convex surface. Cones are also called cones of revolution, because they are generated by a right triangle, spinning about one of its perpendicular sides. The slant height is also known as the generatrix G. Cones are classified as right cone, whose axis is perpendicular to its base. Oblique cone, whose axis is not perpendicular to its base. And frustum of a cone or truncated cone, which is a portion of a cone, with no vertex, bounded by its base and another parallel surface that was sliced. Given a cone, we can cut through one of its slant heights to unfold it. Without considering its base, the remaining area is the conical surface. As seen, it has the shape of a circular sector. And this area can be calculated as pi times the radius times the slant height. Let's derive this formula. Using the circular sector formulas seen in previous videos, L is the arc length, and it is also the base of the circumference pi times the diameter or 2 times pi times the radius. R is the radius, and it is also the generatrix or slant height G. The circular sector has an angle theta and A is the area of the circular sector. By isolating theta from the arc length of the circular sector, we substitute the obtained value on the formula to find the area of a circular sector. Also, substitute the radius r as G. Substituting the value of the arc length as the base of the circumference results that the area of a conical surface can be calculated by multiplying pi times the radius times the slant height G. Let us remember that the slant height or generatrix is the hypotenuse. To find the total surface area of a cone, first, calculate the area of the base. Then, calculate the area of the conical surface. Finally, add all the areas. The diagram shows the base of the cone as a circle, hence, its base is pi times the radius squared. And the area of the conical surface is pi times the radius times the slant height. Adding these two areas results in the total surface area of the cone. In this first example, find the total surface area of a cone with 3 feet radius and 5 feet height. First, sketch the cone with the given measures. Then, unfold it to analyze the surface area to be calculated. We can see the circular base and a circular sector as the conical surface. Hence, to calculate the area of the base, multiply pi times the radius squared, resulting 9 pi square feet. Then, let us find the area of the conical surface, which is pi times the radius times the slant height G. But we do not have the slant height, which happens to be the hypotenuse. So, using the Pythagorean theorem, the slant height G is the square root of 34. With this result, we can calculate the conical surface as pi times the radius 3 times the slant height square root of 34. If we add these two areas, results the total surface area of the cone, approximately 83.23 square feet. In previous classes, we saw that the volume is the quantity of space enclosed by the surfaces, which bound a solid. The volume of a cone can be calculated the same way as a pyramid, but considering a circular base. Hence, the volume of a cone is the area of its base, pi times the radius squared, times the height divided by 3. Let us calculate the volume of the previous cone. The area of its base is pi times the radius 3 squared, resulting 9 pi square feet. Then, multiply it by the height 5 feet and divide it by 3. Hence, the volume of the cone is 15 pi cubic feet. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com